Welcome to Brain Vision.
Hi there. So in this problem, we're given the following information. We're giving Ohm's law, V equals IR, and plus these 4 other bits of information. So the only thing we'll have to tie them all together is using this formula and looking at the derivative of both sides. So if we think of the derivative of V with respect to t, now we're given that, right? But the important part is we can get the right side a little easier. Right, so we know how to calculate dv dt. Since v is a function of I and r, we can just use the chain rule. And the chain rule says that dv dt must also equal partial of v with respect to I times di dt plus partial of v with respect to r times dr dt. And at this point, we have almost everything we need to plug in. So dv dt, that was given to us. That's negative 0.01. Good. Partial of v with respect to I, we can calculate, of course, by looking just at this formula here. So the partial of v with respect to I, if you just consider I to be the variable, then that derivative is just r. Okay. di dt, well, that's what we're asked to find, so we wouldn't expect to know that yet. Partial of v with respect to r, again, we'll look at our formula here, v equals IR, and this time the derivative with respect to r is just I. And finally, dr dt, we are given that one, that's 0.03. So we have negative 0.01 equals, we're also given the current values of r and I. So now we have everything we need. R is 400. Oops. Times di dt. I is 0.08 times 0.03. All right. And let's see. So our final value of di dt will move this term by subtracting it from both sides. So we have negative 0.01 minus, let's see, 0.08 times 0.03. And then we'll have to divide all that by 400. And that will give us our value of di dt. So we can just plug this into a calculator now. And we will get negative 0. Make sure we get all the zeros here. Let's see. 0, 0, 0, 0, 3, 1. And our units, we can look back at our given information, but since I was given in amps, that'll be our unit, and our time unit in this problem is all seconds. So there's our final answer for how I is changing. Hopefully that helped.